Hello, I'm gonna implement find in files today using Janet. I'm Saikin, of course. First of all, I'm gonna create a directory, my directory find files. Oh, oh, I thought I had removed the directory already. I just wanted to show you that I'm creating a blank directory, going into find files. And first we're gonna write down what we're supposed to do. So I write Freja and just goal. Freja is the text editor I'm working on. So of course I'm gonna use that for note taking as well. So the steps we want to take are first of all, we need to be able to open some file. So open a file, then use peg match to find something in that file, to find search term, and then return I would like the start and end of the search term. So we want something like this: return value, let's say path to file, and then the start maybe 123 and the end like 150. So the path, the start of the match, and the end of the match. Okay, so this could be like the first module or whatever. Module, or rather this is a function. We could call it like the find function find in file, which would take path and a peg. Or yeah, let's start with the peg expression. That will be great. Peg is of course Janet's or not only Janet's, but it's what Janet uses in place of regexp to do what regexp do, like find things in files. You can write parsers and stuff with it too, but we're not going to do that today. Then the next step is we need a function for finding in multiple files. So we could point to a directory and it would run find in file on all files recursively in that directory. So we could say find in files and say start path and peg expression. And this should run find in file on each file in the directory. Oh, whoops, is this too? Okay. Directory, and in each file in each sub, or we could do it like this instead. Run finding file on each file in the directory, then run find in files on each subdirectory. So we get a recursive function. And then the return value should be like the above, but with a vector of, or not a vector, an array, sorry, a tuple of tuples. So something like this. Okay, so that's what we're gonna start with. We'll see how far I get. I'm gonna code for about half an hour or so. We'll start then by implementing this find in file function. So I'm gonna create a new tab, Freja, and call this find file.janet. And there we go. So we can start by writing the definition then. Define find in file path peg expr. Great. Okay, so first we need to open a file using this path. I'm also gonna call this like this, find in file. And we could start with finding something in this goal file, which would be at home, or I guess it would just be like this, go, or maybe this. We'll see. And then in goal we would like to find, let's say we want to find, or no, we want to find file instead. There we go. And now we'll see here. Now if I hit Control L, it will save the file and run do file on it, which means it will just run all the code in this file. So right now nothing happens. We can just verify that something happens by printing the path. And maybe we could even say something like looking inside file path. And now I hit Control L again. Now we get this looking inside file. Maybe we'll even do something like this, print, just to get some blank spaces around the start and the end, like this. There we go. So we have the start and then our code running and then the loaded file afterwards. So first of all, we need to open this file and to be able to apply pegs to it. So, and I have no idea how to do this, or I have a little bit of idea how to do this, but I don't remember. So I'm gonna Google for Janet Core API, and here we'll see if we find something. We have the file under API. That sounds great. Is there a, I think there's a with thing we can use too. With, let's see, I think it's here. Yeah, so you can use with to have files being closed automatically. And that's, I think that sounds good. So start with, and then the file we want to open, F, and we open the path, and we only want to read. So we can check file open what arguments it has. So we say doc file open, and now I don't want to run the whole file. I just want to run the last X expression before my cursor. Then I hit Control Enter, and then I see it evaluates doc file open, and then we can see the documentations. And we want to read from a file. We don't need to write or append or anything. So we need to add the mode flag read, I think, if that's not the default. So we say file / open path, and then the keyword R for read. And then we do this, and then we just do this, close everything up. I create a comment here and then hit Control-Shift-F for formatting. This is because if I remove this and hit formatting, it closes everything up. But I want to make it easy to add stuff into the with part of the code. So now we open a file, and I'm just gonna hit Control L to load the file, and it seems to work. Maybe we can pretty print the file. PP is like print, but instead pretty printing, which means if you're looking at a tuple, for example, it will show the actual contents of the tuple. But with a file, it will only print this. But at least we get the file, so that's great. That's perfect. Okay, and here we also see how we can read the file. So we can try that too. Let's try print, read the file and all of it, I'm guessing. And then I hit Control L, and that seems to work. That's great. We managed to open a file and look at it. Everything is going smoothly. So we're done with step 1. So we can add a, I don't know, an OK here, or maybe in the beginning. Okay. Okay, so now we want to use peg match, and I don't remember. I don't remember exactly. I think we can do this again. We do doc peg / match to check the docs, and I hit Control Enter again to run the S expression before the cursor. So here we see with peg match we give it a peg and a text. We have the text and we have the peg. Cool. So we could just try running them. Peg match, and here's the text. Peg match and the peg. Maybe we don't. Maybe this could just be called peg instead. Maybe it doesn't make sense to say peg expression. Anyway, so file should go there. I'm gonna pretty print this too. So this should be the result of finding file now. So now I hit Control L, and we get nil. Let's see. Peg match, peg text. I thought this, oh, that's right, this will match, let's see. This would only match if it was at the beginning of the text, I think. If we did this, I save it now and hit Control L again. Yeah, now we get a match. Everything that's not nil is a match. So the expression right now searches for file, but only in the beginning of the file. And we need to do something that searches for every occurrence of file inside the file. I don't quite remember how to do that, so I'm gonna look a bit at the documentation. This is not the right window. Here we go. And we have, let's see here, parsing expression grammars. And here we'll see. Oh, right. Here we can do an option like this. Let's see. I think we do this. We say either file or one, which means like anything. One means matching against anything. And now we load. It still doesn't work. Then we'll look here again. Oh, right, wait. Oh, sorry. This, what do you call it? Asterisk, or that means and. So now I said I want file and anything, but I wanted to do this, which is more like or. File or one. So we hit load again, check the terminal. Now we find some matches. Good. The problem is this is not very interesting. This is not what we want. We want the path to file and the start and end of match. And I realized now we even might want multiple matches, because maybe file appears multiple times in a single file. Like that. So what we do then, first of all, we can start capturing the positions. So in this case, if we want the start of the file, we say we want the plus means or, so we want this or anything, and this is we want the position followed by file. So in this case, we should get the position, I guess byte position right here before file. I hit load and see what we get. There's nothing happening. Brilliant. Hello? Yeah, something is happening. Okay, this is the position. Maybe we need to capture it too then. I thought this would be enough. Let's see. I'm gonna see here. Position. Okay, maybe we need to capture it too then. We'll try doing this. What am I doing wrong? Capture. So what's happening now is that we match properly, but we also need to capture the position, which means tell the peg to actually store the position and give it to us. And I thought this would be enough, but it's obviously not. So then I tried doing the arrow to capture the position, but that doesn't seem to work either. Oh, one thing I'm realizing now is that I'm not even sure it finds file. Maybe it just finds one. So we could try doing this just to make sure, or to see what happens if we try to get the position. Yeah, exactly. There we get 0. Oh, now I see. Okay, so by default, or the way I've written this grammar, let's put it on a new like this maybe, is that it will only search one time. It will search for file or one and then just stop. We need it to search as many times as it takes. We can check here at the bottom at example. Oh, so we can use any for that, which means, I think it means 0 or more of these. And then I think it will keep on going. We'll try it. Now I load again. There we go. Now we found every single position of 1. We don't want the position of 1. So I remove the position getting thing and hit Control L again. And now instead it looks like we're getting what we're looking for. So if I hit right 22 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So that looks about right. So that would be the starting positions that we're looking for. And then we need the stop positions. So I do it like this, hit Control L again. And now we get them like spread out like this. I think we can replace this. Or let's not do that right now. Anyway, with our finding file, I'm not sure. I think we're gonna keep it simple for now and just add the string here, so file, and then we say that this is text instead, and define the peg like this. And then we can splice in, let's see, oh there, splice in the text like this, and load, and yeah, we're still finding. And now if I write like steps, it should find this one. Yeah. Cool. Now we can take these, and I think we have partition, because what we want to do now is to group the start and end together. So we write partition 2, hit load file, and now we get the start, end, start, end, start, end. So that's great. And I realized we only want the start and ends here, because the path we already have the path. So we don't need to return the path as well. That would be silly. We already have the path. So we get the tuple of tuples with all the start and stops of found matches. And I hit save there, load this. Looks great. So we have OK here and OK here. So now we can find stuff in files, it seems. Seems that way. We can remove this now because we won't add any more to this function. Next step then is applying this find in file to many files. I realize also maybe I don't want this to be that simple. We want a peg here instead. And then we just do like they suggested, we do a finder function like this, finder. And here we take a text, and here we do this thing. So in order to keep like finding file as generic as possible, it takes the peg. And then if we want an easier way to do something, we call the finder like this. Let's see. There we go. So now it's slightly more code while calling the find in file, but now we can write any peg we want. So find in file is more like peg in file or something. Anyway, okay, now we can start working on the find in files. I'm just gonna drink a bit of water. Okay, so to do this, we need to first figure out what files are in a directory. So I'm gonna put this in a comment block, like this. So now when I hit Ctrl L, it won't run find file. I put it at the bottom, like I often put example calls like this in comment blocks. And now we start writing our find in files. Find in files. We take a path and a peg. And first of all, we need to figure out what files are available, like files or maybe content of the path. Something like this. We say, let's return content for now. And then we print find in files, and let's just look at the current directory, and we can keep looking for finder file like this. Okay, we don't have a function called question mark, question mark, question mark. We must instead find some function that gives us the files in a folder. And I hope this is available in the file module. Seems like a good place at least. Or maybe not. Maybe this only opens files. Is there maybe like directory? Expand path? No. CVD. OSDir. Here we go. OSDir. Iterate over files and subdirectories in a directory. Returns an array of path parts with only the file name or directory name and no prefix. Oh, that's not quite what we want, I don't think. Gonna check. Let's try it. OSDir. Nice. And remember, path now is this thing. If we want to, we can make it even more clear by writing this and then hitting Control Enter, and we'll check the terminal. Okay, this looks like what we want. We're gonna try to create a subfolder like this, my dear subfolder, and in the subfolder we create nice to see you .janet. Okay, and now we run osdir on the current directory again. So we get the subfolder, but not the file in the subfolder. Maybe we need to run it on that folder too then? Or does this need to contain something? Hello? Cat, nice to see you. Hello, cool. Now we run osdir again. Nope. What happens if we run osdir on subfolder? Okay, then we get nice to see you. So if I guess correctly, we need to call osdir again on subfolder, but that's fine. So now we need to figure out which, so these are like the files and folders. Files and folders. I hit Control L. We get nothing because I don't pretty print. And do it again. There we go. Now we need to figure out which are files and which are folders. Let's see. Let's just try running file on them, like map file open, and see what happens. So we run map, which means run this on everything in this. So in this case we run file open on subfolder, on find file, and on goal. And we get a file. Everything's a file. But how do I know if it's a folder? Directory. Gets information about a file or directory. That sounds exactly like what we want. So we try instead osstat and hit Control L. Oh wow. Okay, it looks like we only got one. Shouldn't we get multiple? No, okay, here's the gap. So mode directory, mode file. I'm guessing we could filter on that. So I wonder if there's a split function. Split, so we can split on which are folders and which are files. Split. No. Is there Juxt? There is. Then we could. I'll just do this. Files. Or we're gonna do. Yeah, we do this. Filter. Map osstat. Let's see. Files and folders. So first we'll map that, and then we filter where the mode of the thing, or like this, sorry. When the mode of running osstat on a path is equal to folder, or file rather, it should end up in files. And let's just return files for now. So now we shouldn't get subdirectory. Hit Control L, see what happens. Oh, this is not what I wanted. Now it returns the map osstat thing. Or maybe I want the osstat thing. I don't think so. No. So instead we run osstat in the filter. So we get the path instead of getting the OS stat result. There we go. So now we get find file and goal. And now we get directories or folders where mode is equal to folder instead. And we do this. So files and folders. I guess it wasn't folder. Let's see then. We run OS stat on the subfolder. It was mode directory. Okay. Directory. Okay, there we go. So now we have an array of files and an array of folders. And I know this isn't like optimal to run. We should only go through this array once, but now we got through it twice. But I think the code looks a bit nicer, so I'm gonna keep it like this for now, and we can make it faster if we need to. I mean, if you want something really fast, you should probably just use Silver Surfer instead. But I wanted to try this since I want to use this in Freja. I don't want the user to have to depend on external applications for basic stuff. So I figured I'd try to make a dumb finding files, and then the user can use Silver Searcher. Is it Silver Searcher or Silver Surfer? Anyway, if they want to. But for now we do this dumb implementation. So now we go to find in file. We map finding files in files on all folders. Like this. Let's see. For each folder we want to run finding files on the peg. But we wait a bit with this one and focus first on just running the peg on the files here. So we do map this finding file instead. Find in file with the peg. I realize now that maybe the peg should be the first argument, because I think it's more common that you would use partial finding files peg than partial finding files the path. So I'm gonna move everything over like this and then fix our example here like this. Fix that. I just want to make sure that this function still works. No. Why doesn't it work? Unknown symbol find in file. All right, that's true. Let's do this. Yes, good, it works. That's right. As Freja works right now, if I hit Control Enter, it will run the code in a different environment than when I hit Control L. Rather, in both cases it runs in a completely new environment. I'm gonna fix that so that there's an environment tied to the file, so you can use Control L and Control Enter together. But right now you can't. So we keep using Control L for now. So back on track. We map over files, and for each file we want to find in file. Now I hit Control L. Expected string, but got tuple in OS there. Line 16. Path. Oh right. I changed the positions of the argument. Now we do it again, and this seems to work. We get the start and stop positions, but we also want, so here we do like this, tuple, we want the file name there, and then like this. There we go. So now we get finding files and all matches, and then goal and all matches. I wonder if we should get the absolute path. Probably not. But I think we're gonna append this path, because otherwise we will mess up when we do the recursive thing. So we do string to append path to this. Now hit Control L. Now it looks like this. That's pretty nice. Okay, so now to get the sub directory thing. Let's see, we could concatenate these two. Hit Control L. Concat was not the right. Oh, it's array concat. So we concatenate these two and get bad slot. Oh, right. Here as well we need to do this. But now, instead of doing an anonymous function, we could use partial if we want to. But I don't know if we want to. The code got shorter, like, whoops, like this. So we'll keep it like that. Anyway, expected key in integer. Let's see. Line 17. It seems that this one is an array. Or no, it's nil even. Let's see. We can run trace v on this one to see what it contains. Trace. So that looks okay. Maybe it's this one that's nil then. We run trace v on this, the OSTat thing. And there we got nil. So we're gonna check what we got nil on. And I think I know what's going on. Yeah, it can't find nice to see you, Janet, because we need to add a path here. So string path, like this. Oh, right, and the path, we need to add string path and then at the end a slash. And just to show what I'm doing here, like this $sign is the folder we got from running OSDir, and it's only like the folder name. Let's see. So this one is the one we got from OSDir, and it's only the folder name. But if we want to run OSTat on it, we need to have like the full relative path. So I add the path so far, which would be /, and then the thing we got from OSDir, which was subfolder, and then we add a trailing slash. Now I think we can remove some of the traces, because it gets a bit confusing with too many traces, I think. Like this. And we'll see. Still error on... No, it's on line 19 instead. So we need to do the same here. String, path, and the $sign, load file. Tries to... Now it dies. This close invoked on nil, I think close is being run at the end of with. So for some reason it gets nil here, I think. And we can validate this by writing trace v, hitting Control L. Yeah, it's nil. And for what path is it nil? We have looking inside path. So it's nil for nice to see you. Why did it try that? Let's see, find in file. Oh, we need string path here as well. Okay, that's better. So now we can remove the traces. Was there any more traces? Yeah, here. There we go, hit Control L. This looks fine. We can add a file mention in nice to see you, Janet, to make sure... Oh, so Freya, nice to see you. To make sure that it actually finds file in here. Hello, file. How nice to see you, file. then Control L, and now we see in Nice to See You, we find the file, and that's what we expected. And this is great. So now we get an array of arrays. Maybe we could turn this into a table instead, with the file names as keys. But first we can say we do this, okay, and we run each of those. Now the return value, we could yeah, we'll remake this to a table like this, and that would contain something like this. So the paths are the keys, and then we get arrays of the results, something like that. So instead, let's see, then at the top level, so not the recursing part, I guess the easiest way to do this would be to do something like this. So now this one will do all the recursion, and then we create the user function that will turn it into a table. Or I guess we could even pass a table around and have it being put into. So we could do this instead. So we do an optional table result argument, and then instead of doing map, we can do let's see, we do loop, and for each value in, let's see, like this, for each value in folders, we say let the result be found in files. Let's see now, and then we need to loop here, default res, and we create if we don't get past that table, we create a table. At the end we can return the table. So then we do for each being folder. Oh, we just did this, of course. That and parentheses too many, I think. Yeah. So instead of creating new arrays by using map, now instead we just call finding files again, and then when this is for looping through the folders, and this is the part that loops through the files. So now while looping through the files instead, we can do like let matches. Let's see here. Oh, we can do this too then. Let's write file path would be this. And the matches would be the finding file file path. We remove this map. Let's see, what did I do wrong here? Oh, double square bracket. Okay, and now we actually start gathering the result instead. So we say put into res, we want to put file path and then the matches. and I hit Control L, and it doesn't work because we have a $sign here, which doesn't make any sense. That's V instead. This is V. The expected array table, line 28, put res file path. Wait, why is res a tuple of all things? Let's see, we do trace v res load. It's a tuple. Why is res a tuple? Do I use res somewhere else? Res. Oh, right, it should be opt here, I think. This means like all arguments after the first two will be put into a tuple, but we want it like this. Yeah, so now we instead say this argument is optional. Okay, so now in find file we got these matches, in goal we got these matches, and then in the subfolder we got these matches. That's pretty nice. So that's what we wanted. So let's put an OK here as well. Cool. So that's finding files. I'm gonna put this on GitHub so you can check the code and try it if you want to. And that's all for this time. I wish you a nice day. Bye bye.